Okay, so in physics today, we're in this 1.3. Talking about accuracy, precision, and significant figures. So I think you kind of understand this, at least accuracy and precision, pretty good. Accuracy, of course, is getting close to something, the real measurement. So, like on a target, if you hit the bullseye, you're pretty accurate. Precision is repeatability. So I can repeatedly get off the bullseye, but if I'm hitting the same spot each time, I'm precise. I'm just not accurate. So in this example, you're pretty accurate because you're trying to get to the bullseye. Here you're real precise because they're real close together. You're just not accurate. So to be precise and accurate, I would have to move these to the bullseye. Now, uncertainty is a measure of this related to these things. So that how far away from you from the actual is your uncertainty. Sometimes you might have, see this referred to as the error in something. So they give an example here about a piece of paper being, we think a piece of paper 8.5 by 11. Well, if you measure it real close, it may not be 8.5 exactly or 11 exactly, but it'd be real close. So the uncertainty is how much variation, if you will, there is in that measurement. It's affected by the measuring device, the skill of person measuring, irregularities in the object being made. It could be even affected by something like temperature and stuff. Let's see, we actually did not talk about this one because we were getting pressed for time again in class, but this is a good example. If you had the thermometer that was uncertainty with 3 degrees Celsius, Celsius is different than Fahrenheit, so 3 degrees Celsius is a pretty good range. Could you even use that? And the answer here, if you read this, is not really, because, it could be off so much in either direction, you're not really even know if the kid's got a fever. A lot of time uncertainty is measured in percent. Okay, so you have to remember back when we're doing percent, if you take your decimal, you say it times 100, you turn it into a percent. If you've given a percent and you want to use it in math, some calculators have this percent button, but I usually just turn it back into a decimal by dividing it by 100. So we're going to be doing equations here for homework that are using percent. Here's an example we did in class. We talked about in class, if I go buy a 5-pound bag of apples, well, it's probably not going to be exactly 5 pounds. So it should be within a range though. And so we look at 4 of them and here are their weights. So we determine that it has an uncertainty of plus or minus 4.4 pounds. So think a minute of how we came up with 0.4. Looking at these measurements. And you can pause this video if you want to, but anyway. So we look at the difference in these and 5. So that's 0.2 away, this is 0.3 away. This is only 0.1 away, but this is 0.4 away, so that's got the most variation. So our measure of uncertainty is 0.4, that's the biggest one, plus or minus 0.4. Then we want to say, well, what is that in a percent? So you just take that 0.4, you divide it by that 5, you get a decimal, then you multiply it by 100 to turn it into percent, and you get 8%. Now, sometimes your variation is written plus or minus percent, but sometimes it's written plus or minus just a value. Let's see. We did, did we do this? Yes, we talked about this question, so you might want to look at it. If it's got plus or minus, you could add or subtract the 5.05 from this number in either direction and this number in either direction. If you go down here and go up here, you get like the same number. So you can't conclude that this guy's even running faster if you've got that much variation in your stopwatch. So you need to do something more accurate than that. All right, then we talked about significant figures. So this could be a question if you take an AP test. I may have a few questions on this, but significant, I'll try not to trick y'all. But the significant figures, if we see this number right here, 1, 2, 3, all of those are good numbers, so they're all significant. All of these are significant. It's the zeros that we have to worry about. So zeros that are placeholders are not considered significant. So we have this number here, 0.053. Dividing 3 is significant, but these two are actually just placeovers, shifting that over into the thousandths place. So there's only 2 significant figures there. Now here, when you got 10.053, these between numbers are significant because they're not just placeholders. They're telling you about the numbers. So we have 1, 2, 3, 4, 5 significant digits here. Most of the time, if you're going to write 1300, some people will say those aren't significant, but most of the time people agree that they are. So that's 4 significant numbers. If you don't want them to be significant, you want to use scientific notation, which would put that 1.3 times 10 to the third. And then you know that there's only 2 significant figures. Try these. There was something we didn't talk about. Oh, look at B. We didn't talk about that up here. If this ends in a 0, and there's no other numbers past it, they're telling you that something was here and they rounded it, and they want you to have this number. So this is significant right here. Anyway, try those and see how you did on those. Okay, when you're using multiplication in significant figures, your answer should look like your whatever number had the least amount of significant figures, but you don't use the numbers that are in the equation themselves. So pi, just ignore, if we use pi, we could have a number that went on forever, so we don't want to use pi. If there happens to be a 2 or 3 or 4 or something in your equation itself, that doesn't bound you to one significant figure, just kind of ignore the equation itself. But whatever you're given, so like right here I'm given 1.2, so I have 2 significant figures. So my answer should be 2 significant figures. That wasn't the best example, but anyway, here if you're adding and subtracting, you go with your lowest decimal place. I don't know why this was smaller here, but this is only to 1 decimal place, so my answer needs to only be 1 decimal place when you're adding and subtracting. So you can come back and kind of look at that. Don't know. I think we went on and worked some problems, so let's go down to here. You do have number 11 in conceptual questions here. It's actually about accuracy and uncertainty. And problems and exercises, we start 1.3. We're going to try 11 through 28. And we did 11 and 12 in class. So let me look at, you can look at 11 and 12. It says, suppose your bathroom scale reads your mass is 65 kilometers with 3% uncertainty. What is the uncertainty in your mass in kilograms? So all we have to do here, they're giving us the uncertainty. They want to know what it is in a number. So all you gotta do is multiply your 65 times your 3%. And remember though, percent you want to make when you multiply. So we actually want 3% of 65 kilograms is what we're doing. We're going to say that 65 times 0.03 because that's changing that into a decimal. Remember, you can divide it by 1,000 if you need to. And this becomes, what is it? Let me do it right quick. 65 times 0.03 is equal to 1.95. And it is kilograms because we had kilograms and they want their answer in kilograms. But then I have to think, okay, what is my significant figure? This is what I was given. This has 1, this has 2. You go with the smaller, which is 1. So I want to round this to 1. So the answer is going to be 2 kilograms. On number 11. All right, then on number 12, good measuring tape can be off by 0.5 centimeters over a distance of 20 meters. What's the percent uncertainty? So here we have to figure the uncertainty. So we're off by this much over 20 meters. So you're dividing to get your uncertainty. Okay, just go ahead and divide this. You're going to get, what are we going to get? 0.5 divided by 20 is 1 over 40. I could go ahead and put that as decimal if I want to. So that's 0.025, but my units are not right. I have centimeters over meters. So I've got to change this. Okay, so I need to change these units. So I can do that by multiplying by that equivalency thing and put meters on top. 1 meter is 100 centimeters. Okay, and so that my units cancel out, because I'm trying to get 2%. So then I have that 0.025 divided by 100. But then I've got to actually change that to a percent. And to change the decimal to a percent, I'm actually going to say it times 100. So in this case, this is my answer, 0.025, and it is a percent. Okay. Significant figures, I look over here, I've got 1, 2 here. This one doesn't count, but this one does because it's following it by itself. So I have 1, 2, 1, 2, 1, 2. These don't count. So this is my answer. I don't really need to round anything. 0.025%. So hopefully that will help you get started on your homework. Love you.